See, these are the resonance structures of carboxylic acid. With these structures, we can answer one reasoning question. Why carboxylic acids are more acidic? See, when you consider all the functional groups, see, in our syllabus we have alcohols. The acidic side, we have alcohols and carboxylic acids. So when you compare the acidic nature of alcohols with that of carboxylic acids, we find that the carboxylic acids are more acidic. What is the reason for this? See, whenever a compound changes into some other product, if the product is more stable, then it will go for that change. Okay. So when you consider RCOOH, when you consider the acidic nature of carboxylic acid, what happens to the carboxylic acid? It loses H plus. And what do you get? RCOO minus and H plus. And from where is the hydrogen lost? It is lost in the carboxylic acid, COOH group. And how is the COOH group actually present? It is present like the C double bond OH, isn't it? The carbon is connected to one of the oxygens by double bond. Other oxygen is connected as OH. And these are the resonance structures of carboxylic acid molecule acetus. So the COOH group is involved in resonance. And because of the resonance, one of the oxygens connected to the two carbons, is existing as O minus, and the other one is, other oxygen is having a positive charge. So look at this. In these resonance structures, in this, the first resonance structure, there is no charge. This is no charge on the oxygens. But in these two structures, we are able to see that one of the oxygens connected to the carbon is having a positive charge. Okay. Though this carboxylic acid is involved in resonance, since positive charge, see, when we studied about the resonance structure stability, we learned one of the points that if positive charge is existing on more electronegative atom, it is not a very stable one, isn't it? So carboxylic acids, in the resonance structures of carboxylic acids, in the resonance structures of carboxylic acids, positive charge exists on one of the connected oxygens. Which is not very stable. Okay, it is not a very stable contributing structure. Okay, but after it loses H plus, let us write down the resonance structures of carboxylic acid now. So how do we write resonance structures of carboxylic acid? RC double bond O minus. And as usual, if an oxygen is connected by double bond, there should be two lone pairs. Connected by single bond means there will be like two lone pairs, and this negative charge that has come from the loss of H plus. See, when you have RCOOH, this H plus goes off, leaving the bond pair. So this bond pair shifts as a negative charge on this oxygen. So this oxygen, apart from the two lone pairs, it has a negative charge that has come from the shift of the bond pair. Okay. Now, during resonance, what happens? You shift this negative charge here. So this negative charge becomes double bond and this becomes negative. So what do you have? RC O minus double bond O. And one more structure when you are writing. When you shift the oxygen, you just write it in the reverse way. RC double bond O minus. So when you look at the resonance structures, do you see any positive charge on any of the oxygens? There is only negative charge. Okay, here one of the oxygens is having a negative charge, other one is having positive charge. So when you compare the relative stability of carboxylic acid with that of the anion formed after the loss of H plus, which do you find to be more stable? Anyone? Which do you find to be more stable?
After the loss of H plus.
Yes?
After the loss of H plus.
Yes, after the loss of H plus. The anion formed is more stable. Why is it more stable? Because in these resonance structures, we do not find any positive charge on any of the contributing structures. This is, in these structures, we find that the more electronegative atom is bearing a positive charge. And the more electronegative atom always cannot tolerate a positive charge. So relatively, when you compare the stability of the carboxylic acid with that of the anion formed after the loss of H plus, since the anion formed after the loss of H plus, the anion formed after the loss of H plus is most stable, and that too when compared to the anion. See, in phenols and all also, phenol is more acidic than alcohols. There also we say the anion, phenolate ion is more stable, but there the oxygen, there is only a single oxygen which is bearing the negative charge. And why carboxylic acids are anion formed carboxylic acids are even more stable than phenolate ions? That is because the negative charge is delocalized. And one more point you can write. Carboxylate ions are more stable than phenolate ions or phenoxide ions. Why? Because of the delocalization of, due to delocalization of negative charge on two more electronegative atoms. And electronegative oxygen atoms. But in phenoxide ions, the negative charge is delocalized on oxygen and carbon in the ring. So when the tendency of carbon to bear the negative charge is relatively less than the tendency of oxygen to bear the negative charge. So here there are two oxygens which are managing the negative charge. That is why it is even more stable than phenoxide ion. That's why we say carboxylic acids are even more acidic than phenols. Got it? Copy down the reason. This is the very important key point. So what is the key point we have to note? The carboxylate ions. When they ask why carboxylic acids are more acidic, you should say carboxylate ions are more stable than carboxylic acids. That's why it's more acidic. When they ask you why carboxylic acids are more acidic than phenols, then you have to say this as the reason. Clear? Copy down the answer fast. Any doubt? Write down fast.